Good morning, boys and girls. This is the welcome warm-up part 1. Okay, I'm going to see some of you in a little while at a orientation, and I'm going to see a lot of you starting on Monday, right? Monday and Tuesday next week. So this is kind of cool. Getting excited, real excited. I don't know if you guys saw those numbers in the paper this morning, but how many new cases in Sonoma County? All of Sonoma County yesterday? Peace, dude. Two. That's awesome sauce. Anyway, you know the drill. Copy this down. Do your best. Come back and check your answers or get help if you need it, right? Pretend this is a rectangle. I'm not the best drawer sometimes. Okay. All right. See you in a bit. And the bid is up. 42 and 13, most popular diamond ever. What two numbers multiply together have a product of 42 and you add to have a sum of 13? That's going to be 7 and 6, right? 256, Mr. Daniel's favorite number. 16 times 16 is 256. 16 plus 16 is 32. 5400 and 1 5/10. How about if we go 9/10 and 6/10, right? Number 6 times 9 is 54. But in order to pretend that was a 6, I had to move the decimal over one spot to the right. In order to pretend that was a 9, I had to move the decimal one spot to the right. I had to move decimals over 2 spots total, so I have to go back 2 spots in my answer. Boom. And when I add, remember what you do when you add decimals is you got to stack them and line them up. And I don't know if you noticed, the first thing I wrote in that second number, 6/10, was the decimal, because that has to go right underneath the other decimal. Then I put the 0 and 6. Now, when you go add, you just put the decimal straight down and start adding. 6 plus 9 is 15. So carry the 1 and 1, 0, 0. Boom. All right. Do you guys remember this one? This is a tough one if you don't remember it. This is 4 and 2.5. Remember, 2.5, 2.5 is 5. So I got 2.5, 2.5, 2.5, 2.5. That's 4 times 2.5. 5, 5, 10. Live long and prosper. Okay, sorry for those bent fingers. Years of basketball. All right, 4 plus 2.5 is 6.5. 3 to the 4th power is not 12. It's 3 times 3 times 3 times 3. 3 times 3 times 3 times 3. That's 9 and 9, 81. Right? Or you go 9 and 3 times 9 is 27, and 3 times 27 is 81. 5 to the 3rd power is not 15, and it's not 75. For some reason, a lot of people get that first part right. They go 5 times 5, get 25, and then they do 25 times 3 instead of 25 times 5. 125. 2 to the 6. 2 times 2 times 2 times 2 times 2, right? I'm going to have 2, right? So I'm going to have how many of these things? I'm going to have 6 of these things, right? Now, I know that 2 times 2 times 2, or 2 cubed, is 8. So 8 times 8 is 64. Now 6 squared is 6 times 6. 9 to the 3rd power, you can almost do in your head. If you know how to do distributive property in your head, right? You got 9 times 9 times 9, right? That's 9 cubed. Now you know 81. Now when you think this in your head, this is 9 times 80 plus 1. And you could do 9 times 8 in your head, and you could do 9 times 1 in your head, right? Because 9 times 8 is just like 9 times 80 is just like 9 times 8, right? It's 72 to 0. So you're thinking 720 plus, not plus 1, plus 9 times 1. And you can do 720 plus 9 in your head. You guys are pretty close. Some of you already doing it, doing 9 cubed in your head. Who would have thought that when this school year started, right? And remember the trick with tens and powers? It's a 1 with that many zeros. So I got 4 zeros, 10,000. So that means 10 to the 6 is a 1 with 6 zeros, which is 1 million. Now, 1 to the 10th is 1 times 1 times 1, 10 times, right? It's going to be 10, right? No, it's 1. 1 to any power. When you go add fractions, you got to make sure that you have a common denominator. So I'm going to write this underneath here. I'm going to squeeze in my equivalent fraction for denominators. Now, 2 and 7 are both prime, so I'm going to go 2 times 7. Say I'm going to go to 14ths on this. I did 2 times 7 to get 14. I go 1 times 7. Okay. I did 7 times 2 to get 14. I don't put a 2 up here. I go 3 times 2. And now I have 7/14 plus 6/14 equals 13/14. And 3 and 2 is 5. Okay, same idea here. But I'm lucky here. Although I have to change the denominator, 3 fits into 9. So I'm going to change these to ninths. Okay, and here I go 3 times 3 is 9, 1 times 3 is 3. Now I'm unlucky because I have 2 ninths and I'm trying to take away 3. So I need some more ninths. Anybody know where I get some more ninths? 7-Eleven? Walmart? Home Depot? You're going to borrow from the 18. Okay, so I cross this out, and don't go to your standard algorithm when you're subtracting and borrowing and go put a 1 in front of that, because then you're saying that that 1 whole that I borrowed from the 18, okay, I'm changing 2 ninths to 12 ninths. That would mean that that 1 whole equaled 10 more ninths. Well, that's not true, is it? How many more ninths am I getting when I borrow 1 whole? Well, hopefully you said it's got to be the same on the top. So 9 more ninths. So I borrowed 9 ninths. I had 2. Now I have 11 ninths. I see that? 11 minus 3 is 8. And then 17 minus 4 is 13. Okay. And again, I've said this before. Subtracting mixed numbers with unlike denominators when you have to borrow. Even saying that problem's hard. It's one of the hardest types of problems you do in 6th grade. Okay? All right, now there's 2 ways of doing this, probably more than 2 ways. I can do the C method and change these into improper fractions, right? Remember, 2 times 2 is 4, plus 1 is 5. So that's the same as 5 halves. And 5 times 4 is 20, plus 2 is 20 to 22. That's 22 fifths. And I can multiply across top, across the bottom, okay? But I could also split this up. And the generic rectangle is a good way of doing this. Say the 2 1/2 and the 4 2/5, and go 4 times 2 is 8. 4 times 1/2 is 4 halves, which simplifies to what? 2. 2 times 4/5, 2 times 2/5 is 4/5, and 2/5 times 1/2 is 2/10, which simplifies to 1/5. So I have 8 and 2, 4/5 and 1/5. Well, guess what that's going to be? 5/5. 10 5/5 simplifies to 11. Now, remember how you can cross cancel when you're multiplying fractions? I can say 5 goes into the top and the bottom. 5 goes into the top here once. It goes into the bottom here once. 2 goes into the top and the bottom. 2 goes into the bottom here once. It goes into 22 11 times. Now my problem is 11 times 1 on top, 1 times 1 on the bottom. How hard is that? And 11 over 1 is 11. Okay, so sometimes simplifying before you start makes it easier. Otherwise, you're doing 5 times 22, which is 110. 2 times 5 is 10. And you're going to say 10 goes into the top, 11 times goes into the bottom once. Still going to get the same answer. Okay, now this big, huge problem is what we call an OOO problem. What does OOO stand for? Order of operations. What do you do first in order of operations? Always do the parentheses first. They can be normal parentheses like that. They can be those fancy ones. They can be big old brackets, right? But you're going to do those first. Now, inside that, I have exponents, subtraction. Remember what that is? Square roots, multiplying the more exponents. So I'm supposed to do my exponents and square roots first. Square roots are just like exponents backwards, right? Okay, the inverse operation, the opposite. Now I know I'm going to do this exponent first. 16 squared is 256. What number times itself equals 49? What number squared is 49? 7, right? So the square root of 49 is 7. 2 to the third power is not 6. It's 2 times 2 times 2. It's 8. Now in these parentheses, what's left? Subtracting and multiplying. What happens first? Well, hopefully you remember you had to multiply first. Okay? Because when you multiply first, the product of 7 and 8 is 56. And now I've got 256 minus 56, which is a nice even 200. You didn't do that. You didn't do it the right order. You not only got it wrong, but you made your problem way harder because now you got 256 minus 7 is 249. 249 times 8. Oh, man. Yeah, that's not easy. This is easy. And plus, now what's this backslash mean? Divide. 5 squared is 25. And 25 fits into 200 easily. All right. Now, did anybody get scared of this? Look at it closely. What do you notice? Same thing on the front is on the top is on the bottom. So anything with the same on the top and the bottom equals 1. Yeah, that was your friend. Don't be scared. Look at it closely. Sometimes you recognize it. Now, how many times is 25 going to 200? How many quarters in $2? 8. Big snowman. 8 plus 1 is 9. Okay. Now, this problem had about 20 steps. You can do 19 of them right and get the wrong answer. The key on these type of problems is how did you go about solving it? Did you show every step? I know where this 8 came from. It came from the 200 divided by 25. I know where the 1 came from. It came from this one, from this one, from this one, from this big, ugly, scary fraction that it ended up being my friend. I know where this 25 came from. It came from 5 to the second power. I know where the 56 came from 7 times 8. I knew where the 7 came from, the square root of 49. I know where the 8 came from, 2 cubed. Okay, I can trace all my, so then if I do make a mistake on one of those 20 different steps, I know exactly where I made the mistake and I can fix it. If you're not showing enough work to do that, then it's not just that you got it wrong, but you kind of wasted your time getting it wrong. You didn't learn anything. You got to show your steps, okay? Believe me, slow is smooth, smooth is fast, okay? Take it slow, you'll learn faster, okay? All right, area and perimeter. Area, I'm just going to multiply. This is a rectangle, okay? So I'm pretending like that's 212 and 84, and I'm multiplying. Placeholder. 8, 9, and 16, 8, 10, 18. Now, I pretended that was 84 by moving the decimal over 1. I pretended that was 212 by moving the decimal over 1. So I moved the decimal over 2 spots. In my problem, I got to go back 2 spots in my answer. Okay, 178.08 square meters. That's the area. Okay. Now, again, what's the other way of figuring out where the decimal goes? Estimate. 20 times 8 is 160. If my estimate's 160, it only makes sense to put the decimal there because that's 178. That's close to 160, right? Much closer than 17, much closer to 1,780. Okay, so sometimes estimating is a good way to figure out where the decimal goes in these. Okay, now the perimeter is all the way around. So I'm going to add these 2 numbers and then double them, okay, because that gets me halfway around. 29.6, and when I go 29.6 and double that, I got 59.2 for my perimeter. 59.2 what? Meters squared? No, perimeter is just meters. Area is the square units. Perimeter of this, 16, 12, and 20. I can do that in my head. 28 and 20, 48 inches. Now, how about the area? Do you remember how to get it? It's a triangle. Half of the base times the height. 8 times 20, but I need half of it. So what can I do? I can do 8 times 20, get 160, and take half of 160 and get 80. But I can also take half of the 20, 10. 10 times 8 is 80. Or half of the 8, 4. 4 times 20 is 80. Either way is 80 what? Square inches. All right, I look forward to seeing you guys soon. Okay? All right. Have a good day, everybody. It's Friday.